Hello again, Math 8. Mrs. Davidson here. I apologize for your last video where I got caught off at the end. I will try not to do that this time. But go ahead and get yourself a piece of paper, a writing utensil, and then answer the question, would you rather see your reflection in a dimly lit mirror, or would you rather see your reflection in a morning lit calm lake? If you go ahead and answer that and explain your reasoning, you can then move on. All right, so this lecture is going to be a whole lot like the last one in the fact that you are going to discover the rule for reflection, much like you discovered the rule for transformation or translation. So make sure that you try everything, even if you're wrong, that you have paused the video and you've tried everything in your notes. It's a really great way to learn. Here we go. Mr. Newman's fourth grade class was actually given this worksheet, and the directions were as simple as this: reflections flip an image. So you would check the boxes that show reflections. Since you can't actually check the boxes, on your paper, describe the shape, right? If you would select, say, the dark blue shape, then I would write dark blue shape. So you're going to pause the video. You're going to select the boxes that you would choose that show reflections, and you're going to write an explanation about why you did not choose the other ones. Okay, so just based on the simple directions that reflections flip an image, those lightning bolts are flipped right over that vertical line. So that is absolutely a reflection. The dark blue trapezoids, or it's not a trapezoid, that's a polygon. I know how to speak math. The dark blue polygons in the upper right-hand corner are the exact same shape and just translated over that line. So that is not a reflection. The hearts have more of a rotation. It is rotated over that line, but it certainly isn't reflected. The yellow moons definitely have flipped over the vertical line, and so that is a reflection. The purple arrows can be argued. While it looks like they are a flipped image of each other, they're not the equal distance away from that line. So some mathematicians would say, yep, that's a reflection, but others would say it's not a reflection over that specific line. There's a different imaginary line there that is reflected over it. The orange trapezoids, hey, that's a trapezoid. The orange trapezoids there, it looks like it's a reflection. But if you notice, it's not quite a reflection. So if you chose that one as a reflection, I'll give it to you. But in reality, it's a rotation and reflection, and that's a lot all in one. The green is absolutely a reflection, and the teal triangles are also a reflection. So good job. Now that we've explained that worksheet, I would love for you to pause the video and expand the definition of what you think reflection actually means. And in that explanation, in that definition, use the word graph. Okay, folks, this is where you need to graph these images so that we can answer all of those questions. You're going to go ahead and pause the video. You're going to graph these images on your notes, and you're going to answer the following questions on the side. When you are done with that, go ahead and unpause the video, and we will talk about the answers together. The figure that is the pre-image is the blue fish, because it is the one where the points do not have a parenthesis. So the image is what has been reflected, and that would be the red fish. And again, we know which one is which because of the prime. And remember, the prime is the parenthesis next to the label of the point. All right, so you are going to go ahead and make sure that you have listed the coordinates for the original and you have listed the coordinates for the prime. All right, so Hopefully you have the same coordinate points that I have for A through D. Now E and F are a little differently because those are going to be more fractional. And so if you wrote fractions for that, that's totally fine. I went ahead and just left them off in my labeling because A through D gives us enough for the rules. So when you're looking at this graph, I want you to think about what axis, what actual main dark line is this reflectioning happening over. So that means that if I were to fold the paper in half, which axis would I fold the paper on to make this reflection happen? And then I want you to look at those listed points and see if you notice any patterns at all. So I'll give you another couple of minutes or whatever you need when you pause the video to answer those two questions. Okay, again, if we're looking at the graph, the axis that we're going to flip over is this one that goes left and right. And so that axis is our x-axis. And again, if I were to fold this image directly over that x-axis, that's how I would get the red fish from the blue fish. Because remember, the blue fish is the pre-image. So when I'm looking at these listed points, I'm going to look, and I'm going to look at just the x values. And I see that my x values are exactly the same. They're exactly the same. But when I look at my y values, they're the same number, but one is now negative. They're the same number, but one is now negative. Do you notice that as well? So the reason that happens is because of our rule. When we reflect over the x-axis, when we reflect over x, our rule is that any point, remember any point is xy, moves. And how it moves is x is exactly the same, but then we're going to multiply the y by a -1, and so it flips the sign for that y value. So if I started out positive, I would have been negative. If I started out negative, I would have been positive. So now that you know the rule, pause the video and predict if we were to reflect over the y-axis. If we were to reflect over the y-axis, what do you think would happen as our rules? All right, so again, you're going to take a moment and you're going to set up your graph. When you set up your graph with this T, Y, and I triangle, you are going to go ahead and list those pre-image points. You're going to try and reflect that over the y-axis and look exactly what that would mean if I were to take it and I were to flip it right along this y-axis. What would end up happening to that triangle? And then you're going to list those image points that you did. What do you notice and what do you think the rule would be? Pause the video, set it up, check it out, try and get that reflection in. Well, if I'm going to reflect it over the y-axis, that means that I'm going to fold it right along the y. And so the easiest way for me to do this is I count how far away from that y-axis is my t. So I have 1, 2, 3, 4. Because I know that t is 5 places away, wait, 1, 2, 3, 4, 4 places away, I can count. Because I know that t is 4 places away, I'm going to now count 4 places over to the right, because then that's going to give me the correct reflection. So 1, 2, 3, 4. That's how I did that point. If I'm at 0, and I'm going to fold it right there, that folds it right on top of itself, so it doesn't move at all. If I go to the I understand that it's 1, 2, 3, 4, 5 to the left, so I'm going to move it from that y-axis 1, 2, 3, 4, 5 to the right. And now I'm going to go ahead and label those points. So my t prime is now 4, 4. My y prime is now 0, 2. And my I prime is now 5, 0. So what do you notice? And again, what I would like to highlight is what do you notice about the x values and the y values? Well, what I notice is that my x values have now changed signs and my y values are exactly the same. So our rule for the y-axis reflection is that our xy point moves, where now I am multiplying my x by -1, but my y's stay exactly the same. So I can actually do it mathematically, or I can do it by counting. So now what I would like for you to do is go ahead and pause the video, and I want you to reflect both triangles over the x-axis. When you are done with that, unpause the video and check your answer. All right, so now what I did was I did all of the counting to make that happen, or I used the rules. So if I'm reflecting over my x-axis, that means I'm folding it in half. So I'm going to count again. So my t, I counted 1, 2, 3, 4 to be to the x. So now I'm going to count 1, 2, 3, 4 to write the line. Notice that I labeled this t prime prime. That's because I'm reflecting my t prime over to make it the new image. I also labeled my t prime prime because this is after the second reflection that I put that point there. All right, so now that you understand what we're doing, or at least have experimented with what we're doing, we're going to move on. And we're going to move on by just having you try a few. Again, I want you to list the rules, go back and look at your notes if you need to, or pause the video and go back and listen to the rules again. And I also want you to label the points. So you're going to list and label all of the points of these. And then when you are done trying those, you're going to unpause the video and check to see if they're right. Okay, some things that I hope that you remembered. I hope that you remembered that when you went from the pre-image to the image, you marked and labeled your points with a prime. Again, if you went from the pre-image to the image, marked and labeled your points with a prime. So from this pre-image, we reflected over the x, and that gave us this image that made it be a prime. But then when we took this prime and reflected it over the y, we now have to label things as a prime prime because it's the second time it got reflected. So that's the way you remember how many primes you need and the order of which that it was reflected. So I want to say thank you so much for your time today. Please make sure that you know the rules for reflecting over the x and you know the rule for reflecting over the y. You can count. You can also know which letter you need to multiply by -1 to make that happen. I hope you have a fantastic time, and we will talk to you another day.